stuff. So just give me around 30 minutes after uploading the video for me to send the link in the group. So let's start. So this practical was based on doubly linked lists, right? So doubly linked lists can be used to realize a list ADT, right? To realize, if you still remember, it means to use a interface, or sort of like extend an interface or inherit whatever is inside an interface. Because in Java, remember, inheritance is achieved, or what is multiple inheritance is achieved through an interface. So technically, when you use an interface, that you're actually inheriting, it's actually inheritance in Java, only in Java. For this practical, you're required to complete the implementation of a doubly linked list. This list should conform to the implementation specifications that have been provided to you. Basically, meaning you should follow the instructions. There are a number of functions that have been removed that you should complete. You must complete the classes and methods marked by this part here, complete code here. And then please note that you should not add any additional methods in the dlist class. So let's put that right there so that we remember that. Let me hide. Okay, I wanted to highlight. So I'm going to highlight that. And then, yeah, or the test class. So remember, the test class is the class that you use to test your code. However, you must complete the full implementation of the node class. So you must implement the node class fully. Quick sorting a doubly linked list. This one will, okay, this is the algorithm. This one will get into that after. I think it should be a second session. For now, we'll see as time goes on. So we have those methods: split, equal, merge, blah, blah, and then that's the required output. The output, you don't have to worry about that. The test.java file handles that. So I don't know what you shared here. Is it what is this? The additional files. Let me see. 366 items. That's too big. No, that's too big. This is not. I thought you guys sent me the additional files that you're given for each practical, which is for this practical. So I already have it, so I'll just unzip it, yeah. But then the next lesson, in the next in preparation for the next week's practical, after we've done for this practical, when we do the memorandum for last year's practical, I have the resources. Since you guys send it to me, we're just gonna use that. So you don't have to worry about that. So the way I'm going to do it is each practical, we're just gonna do a previous practical, last year's practical, so that you guys are well prepared for that practical next week or the following week. So let me open Eclipse, and then I'm gonna create the project and then drag and drop the files. And as you can see, the files are not put inside a package, so I don't have to worry about packages. If you check the practical, that's not the main concern of the practical. There's no packaging. It's not first year anymore. You see, or second year, I mean. You see, you must put in a package, blah, blah, blah. There's marks for package. The main focus is algorithms and data structures. So let me do this. So let me remove this and then create a new project. So create a Java project. Sci. Okay, let me just write in full: computer science 3A practical 03/2025. And then next, make sure you don't choose. You see this part, right? If I don't know, maybe you might forget, or it might be just be activated by default. Make sure you unselect this module info.java file. If you click that, your code is going to have errors one way. I'm not gonna lie to you, it's gonna have errors one way. So you must unselect that. Only use it when you actually know what it does. If you don't, leave it. In most of our practicals, yeah, we don't. All of the practicals from second year, you don't select it. So I'm gonna copy all the files from the source folder. Click here the source folder within my project, and then Control V to paste. And then done. I've imported all the files that I need. Is it the right file? Let me see the node. Oh, yeah, it's the right file. There was no need for them to create the node file class. We're gonna create it ourselves, but then it's fine. So let's start with the node class, right? But then before we get to the node class, we need to understand, let's I list, I don't need it. I'm just opening it, J, but I don't need it. So let's look at this part, right? The thing is, seeing someone's code is very hard. Trying to understand someone's code is very difficult. You have to use what we call critical thinking. So if you look at this code here, right? For example, you see here, they used a constructor, right? Remember when you use the new keyword, it calls the constructor. Remember, the constructor is the builder, it builds the object. So when you use new, it must be accompanied by the name of the thing that you're building, which is node, right? I'm creating a new node. So that new node, in order for it to be built, you must call the builder, person who's going to build it, which is the constructor. As you can see, the constructor that's being called here, it expects three parameters, but we don't know what is what. But we can guess in the next line. I don't know how they expect you to see that, but then yeah, your final year students, they expect you to be prodigies, like to be geniuses. So I don't know how they expect you to do that, but then yeah, that's life. So the node class, right? So let me talk about the node class. So let me open draw.io and leave it there ready for them for doing diagrams and demonstration. Because I noticed if you one thing, even me, linked list chow me. Like I'm not gonna lie, linked list chow me. But then they chow me when I don't picture it. I'm saying it chows me if I don't picture it. Not like they're hard, but then if you don't picture it or you don't write down, even if it's small, stupid diagrams, just write it down so that you can see what you're trying to accomplish. Even in the slides, somewhere, I saw it somewhere. I don't know where the slides or the practical, that PDF that you get for a practical, I think it did explain that. Try to picture it. So that's why I have this open here so that I can demonstrate when we're inserting and deleting and all those things. So let's create the node class, right? So the node class, what things that should it have? So if you look at the W link list, right, it has this. Um, so I'm gonna have value. Okay, yeah. So I'm thinking about how to demonstrate it, so it's fine. It's gonna be like this, and then paste, and then like this. So this is how I'm going to draw each node in the diagram. So this will be, I need to clear around the colors. Let me choose blue here. I'm just choosing any color, man. So orange. So there's my node, right? So let's assume, remember in maths, you start by assumption and then you try to prove your assumption or disprove it. If you remember things like our proof by contradiction or something like that. I think so. I think because I forgot. They haven't done Mets 1B in a while. So this is what would represent a node, right? Each node. So each node can be can so we need to let me but then you can see I don't think it should be an issue, but then it's fine. Let me zoom in a bit. Yeah. So there's the node. So this will represent each node. Remember, it's a doubly linked list, meaning it's double. It's linked on both sides. Just like J. Cole once said, he once made a reference to a rainbow, something like that, if you guys are J. Cole fans. So here, there's the node, and then you're gonna have value here, and then you're gonna have this is gonna be a pointer. So this will be next, right? And then this will be previous, previous, right? Oh yeah, Jacob, he said um she goes both ways. I'm tasting a rainbow, something like that. So yeah, that's what I was trying to make a reference of. So I'm gonna change this to white. Okay, I don't have that luxury. I don't know how. I don't know. Yeah,
He's saying Shori is going both ways. I'm tasting her rainbow.
yeah. So you see, it goes both ways like a rainbow, right? If you know a rainbow, it is both it is both ends, right? So this node sort of like represents that, right? You can think of it that way. There's one end of the rainbow, there's the other end of the rainbow. So this would represent each node, right? So if I have another node here, my laptop screen is very small. You guys have to bear with me. Let me see if I can maximize. Yeah. So this is each node, right? That's the thing. You will see that I'll use this diagram when I'm coding because it's really important or mandatory for you to understand. So this it will be pointing this to previous, right? It stores this node its previous stores the address of the previous node. And then this one's next points to this one. It's like the Spider-Man meme. There's that Spider-Man meme even in the J. Cole song with Drake, the new one, the recent one. As he was trigger, they pointed at each other, making a reference to Spider-Man, right? Saying that it's the Spider-Man meme. It's like basically it's like Kendrick Lamar was not even in the conversation to begin with. It's only the two of them pointing at each other. So if you remember the Spider-Man meme, whereby Spider-Man, there were three Spider-Mans, right? They were pointing at each other, but then you can only take two of them. It's sufficient. So imagine this guy is pointing to that guy, and this guy is pointing to him too. So you can think of it in that way if you want to picture it realistically, right? So it's previous because this is supposed to store the address of the previous node. This next is supposed to store the address of the next node, which is this node, right? And then if there are only two nodes, then we should have a tail. What is this word? We should have a tail and a head, right? They call it a header and a trailer. I don't know why they choose such terminology. So, okay, now, yeah, they should be down here. So we're gonna have this, and then we're gonna have this, right? So there's our nodes, and then this node here is gonna point, its next is gonna point to null. And then this one's previous should point to null too, right? Yeah, it should point to null. So we should have null here. Where's the thing? Okay, I need to minimize. I need a way to represent null. It's fine, I'll just put a circle. I don't have to complicate it. So this will represent null, right? A circle will represent null. I'll write it in, I'll put a text inside so that we see that this is null. This is null, and then this one's next point. No, it's next. No, what am I saying? It's next points to the node. Yeah, it points to this node over here, right? That point, it points to that node. And then its value. No, what am I? Is it? Yeah, it is. It point and then points to now. Its value is going to be now, and then its previous is also going to be now because there's nothing behind it. But then it's next. So that means if you have this node over here, the header or the head, when you call the next method or get next, you should get you the first node. So this is going to point to this node, not to previous. It points to this node. So just know it points to this whole node. And then this one's next. You can just point it to null. You don't, this one's previous. Let me see. You can point it to null or point. to head. Yeah, we can just point it to head. That's also fine. So this nodes the previous address, it points to this one, but then yeah, this will be incorrect. So let's just point it to now. I think that's the best thing to do. It'll be pointing it to now. Because this header, right, or this head is just a way for us to keep track of the first node. But then the first node is the first node, so that means there's nothing behind it. So we shouldn't expect a node behind the first node, if you get what I'm saying. That's the first node, right? So it should be the first node. We can't treat it like it's the second node. Because if you make previous point to this header or the head, that will make the first node actually the second node, which becomes incorrect. So this will be the head, and you can view it into if you want to understand why they use the head and the tail, you can view it in terms of like an animal, like a horse. This will be the head of the horse. That's where it starts, and then this will be the body. You go down, and this will be the tail, the end, right? Its tail. So I'm assuming that's why they chose that example because there's no other reason why they would use that terminology. And then like I said, if these were the only two nodes that were there, so this would be null over here. I totally forgot this. Yeah, just assume it's null. That's the thing about diagrams, man. It's just a mess. Just assume this is null, so this would point to null, right? And then this one's next would point to null. And then its value would also be null because remember it's just a temporary node or just a node to for us to be able to know where's the end, right? So its next is null, and then its previous should also be null because if you say previous, remember what I'm trying to say here. Every time you try to say previous or next, just know it means that node is part of the list, which is not what you want. Because if I said previous to point to this node, that would mean this trailer or tail is actually the last node, which is incorrect. So I hope that makes sense. I hope this diagram makes sense because you can't make previous point to this previous node. No, you can't do that. It has to point to now. Everything actually the tail, you see everything for tail points to now. So I'm going to come here and say this is the tail. Everything points to null. And then here, it's important for the head its next to point to the first node because we need a way to keep track of the first node. If you check here in this class, right, the one that you were given, right, this one that's implemented here. If you check it, there's no last function of I think first. I don't know if first is there. Oh, there is the tail. But then this tail function, it returns everything except the first element. That's a different function. So there's no last function to return the last node. If there was, right, then I would say maybe I would say maybe its value or something like that would point to this node. I don't know. We would have to find a way to use the tail to point to actually the last node. So that would mean, yeah, maybe we'd use previous. I don't know. But then that will complicate stuff. I think that's, as you can see, that if you try doing that, it ends up complicating your code entirely. So that's why they don't do such spiritual things. So for the tail, everything points to now. For the head, previous and value point to now, but the next points to the first node. And don't assume it points to previous, it points just this whole node. Just remember that. So this will be node 1, node 2, and so forth. And then this is the diagram. So I'll be adding and deleting using the same diagram so that you see how the references or the pointers change, which is very important. So since we understand how each node is represented, we can now represent it using a class. So we're gonna call it a node because duh, it's a node. It represents a node. And it has three things: previous, value, and next. So remember what we talked about previous, it stores the address, or in Java terms, right? Remember in C++ terms, address would be the same as saying pointer. In Java terms, address actually means they use the term reference. So this is where reference types come in place. So what is a reference type? If you remember in Java, ComSci 2A, it's not, if you're doing it last year, then you should remember somewhat. But then I'm going to use a simple example, string. The string class, if you say string out, put or out, something like this, and it says it goes to new string, right? Just a simple example, right? Because I just want to revise on reference types. So there's a string, I love Java, right? This is what we call a reference type, right? We are using a reference type. String is a reference type, right? String is a reference type. Why is it a reference type? Because it's actually representing a class. Remember in Java, there's two types, primitive and reference types. Primitive types and reference types. Primitive types, they're just part of the language, like they come with the language, right? And then reference type, you make a class to represent some specific, to create a new data type with that class. Then you can import it. If you notice strings and okay, even though you don't manually import, but then there's imports that are there for strings, things like strings, even the math class, right? Remember the math class in Java to use math functions like cosine, sine, and things like that. So all of that is a reference type. Why reference type? Because when you use the keyword new, this creates memory on the heap. This is what we call heap allocated memory. After it allocates the memory on the heap, it returns the location of where that object is stored on the heap. So basically returns an address or a reference to that object. That's why if you remember the topic in Java about strings, that you can't do this. You can't say, you can output a print statement to compare out with, for example, the string Java, right? You can't do that. Why can't you do that? Because what's going to happen is that it's going to try and compare this address. So this is OX123 is equals to Java. So this is actually what you mean in Java. That's how Java interprets it. So it's impossible. This will always return false. So it's going to be like address. So address of out, where address the address, the address of out compared with the address of Java, right? Which will always be false. So that's why we call functions like equals, dot equals, to compare strings. We always say dot equals or dot equals ignore case and things like that because it's a reference type. It stores a reference. So now that we have a deep understanding that a type of which we use the name of a class, when you use the keyword new, it actually stores the reference to where that object is and not the actual object. So now we know, oh, if I need to create an object, so that means it's anything that is the name of a class. But then if you look at our diagram, right, previous, it's a node which points to another node. So that means I need to use the same type of the class that I'm actually creating because I'm pointing to another thing that's exactly the thing that I am, right? For example, if the Spider-Man meme, if I'm pointing at you and if I'm wearing my Spider-Man suit or my attire, Spider-Man attire, and you're also wearing a Spider-Man attire, and let's say we have a Spider-Man class. If I pointed a finger towards you, right, that means my previous is pointing at you. You point at me, that means your next is pointing at me. So Spider-Man, in that situation, Spider-Man is pointing at another Spider-Man. So hence I have to use node, right? I hope that makes sense. And value is just a value. But then remember, we want our class to be generic, meaning that it should support any type. So we're gonna use T. That's why we use T like this. So another free advice, right? When you have generic classes, the way you can remember it is that the way you name it, right, like this, is actually the way you're gonna use it when you is where you're gonna use it in other classes to declare. So node parameter type T, that's how you actually use it. If you remember array list, guys, try to connect the dots. If you remember array list, you always do declare like that, and then you pass in a type here, right? Which is exactly the same thing here. So that means if array list is like this, that means I can assume when it's the way it's declared, it was declared like this: class array list and then type T. So the way you create the name the class, a generic class, is actually the way how you're going to define it when you're creating that instance of that generic class. So I hope that's clear enough. So I'm going to generate Java doc, right? Because yeah, why not? So I'm gonna have class. I'm gonna call this what are those instance variables, right? Instance variables just means it's a variable that's linked to an instance, meaning that you need to instantiate in order to use them, hence called instance variables. There's just a reminder, you guys were taught this in second year. So I'm going to have declare my variable. So I'm going to have node. Okay, let me start with value. So I'm going to have value. So remember, when you create a variable, you start by putting the data type, let's say int x, right, like this, and semicolon to end the statement. So you declare like this, but then remember it's type T. We're expecting any type. So it can be an int, can be a string, can be double, and so forth. So I'm just gonna say T there. Then I'm gonna name it value. Exactly the way I've named it here. You see value, next, previous. That's how I'm gonna name my instance variables. And then I'm gonna have previous, right? To keep track of the previous node. And then next, if you want to, right? That's why you guys always get copy when you try to help each other. Do you know you can help each other without actually getting a copy? It's simple. Don't just copy and paste and submit. Copy and paste, right? Make differences. For example, on your code, you can just remove this comment and then put a bit of space there. The reason why it gets copyrighted is because it's 100% match. So there's no way you can think 100% alike. And then if I've named it previous, on your code, you can name it prev node, meaning previous node, and then name this one next node, and then maybe name this one val. Simple. That's how we avoid copying if you guys want to help each other. That's free tips. So previous, okay, so I'm gonna have previous, right? And then next. And then if you want to, you can add more extra comments, but I don't see the need for comments here. This should be fine. So I want to keep track of the previous what? Address of a what? A node. So that means I have to declare this as a node. Remember in Java, it's allowed to declare variables, even declare variables of primitive types or reference types, including the name of the class that you're actually declaring. It's allowed. So this stores the address of the previous node and then stores the address of the next node. But then you see there's a warning here because you're using a raw type and it's not expecting a raw type. Remember, you made this class generic. So that means you should parameterize it. It's even giving you advice. That's why I said in order to make this easy for you to remember, the way you name the class like this, that's how you're actually gonna use it when you declare an instance of that class. So that means everywhere where I declare a node, I need to pass in the parameter type T. So that's very important. So there's everything, right? And I know you guys might ask, why don't I initialize the variables, whatever? But remember in Java, anything or any variable that's declared within a class, outside of a function, right? If you go to test.java, I already have a main function. If you declare inside a main function, it doesn't initialize the variable. It has to be a part of the class. So everything that's declared as a variable within the class is gonna get an initial default value. So this will get a value of 0. a default value of its type. Any reference is going to have null. So by default, this is null. I don't have to initialize them manually. That's what I'm telling you. You need to use your Java knowledge and know these things. So I'm going to leave it as it is. But then it's incomplete because it's fine, right? To be honest, it's fine. It's right now it's what we call package private, right? It's now what we call package private. That's the access modifier that it has. I remember there's private, protected, public, and package protected, specifically in Java. Those are the four access modifiers that are available. If you don't specify any, by default, it's package private. It's called package private. What does package private mean? Package private means that you can only access these variables only if you declare a class within the same package that this class is declared in, meaning the same folder. So so then it's still fine because if you check all the classes here, they're inside the same folder, which is the same package, which is the default package. So I can just leave it as it is. But then I want you to understand that, keep that in mind. Because your next practical, you can have minor issues like this because you left it like this, which makes it package private. And that time you're supposed to use it in another different package. So that's why if you're in a scenario like that, right, where you is supposed to use it in a different package, just make it private. Then create an accessor and a mutator for it. So for me, both ways are fine. They're allowed, right? Just know that they're allowed. So I'm gonna leave it at package private because it's fine. It's okay in this scenario. It's gonna work. So we need to create the constructor to build the node. So I'm gonna create a constructor. So public node. I know that I said you should every time where there's node you must put in this bracket and then put in node type T. No. If you listen carefully, I said where you're declaring an instance of this. This is a constructor. I don't need to provide that. I just use it as a normal class as if it's not generic at all. But then the constructor that we need to go back to dlist. So whenever you do your practicals, right, when they say complete or do this class, whatever, always refer to the class that's using an instance of that class so that you get an idea on what you should do. So we need to really think critically here. You see this part here, there's a lot of information that you can get here that I know it's hard, right? It's not an easy thing to see. But then if you think about it, you can understand. If you have diagrams are important. Even next practicals, the other practicals, diagrams are very important. Make them for yourself to make it easier. Even if you have a piece of paper and a pen, that's fine. So you have a trailer or the tail, right? Like I said, the naming convention. I don't know. Is it Mr. Greaves? I think it was Mr. Greaves. Oh, no, is it him? No, it's a different practical. I'm thinking about a different practical. I don't know who wrote this code, but then this person is like, yeah, person is Englished. They know English. So me, the way I know a tail is by tail. It's a tail, not trailer. So we have a trailer and a header, which is just the tail, and we're creating a new node, and we're passing three nulls. So the only plausible reason why we're passing three nulls is because why? Remember, constructors, they do two things. They build the object and they give the instance variables the default values. How many things do we have here? One, two, three. So we have three variables. So that's obviously these three. But be very careful. You need to know the order of how to pass them. This is the way you now need to go back here and then look at it carefully and think about it. So trailer, it is passing all nulls, which is true. Remember the diagram I wrote. You see, the previous, the value, and the next points to null. So you see how important the diagram is. It can help me solve my problem in many ways. This I already knew beforehand, before doing the practical, because I did it right there. It is. I was like, oh, everything should be null. But then this is the part that's going to give me a clue on how to structure my constructor, the head. So you see the head, previous and value, they both point to null, but next points to the first node. So that means the parameter whereby I'm actually passing a value when I'm instantiating a trailer or a header or a head, that actually represents next. So if you check here, I'm passing the trailer first or some value first, meaning this will be next. So this should be initialized as next, which is true because if you think about it, I know that the session is going to be long, guys, but then just bear with me. It takes a lot to demonstrate these things. I want you to see what my mind is seeing. That's why I need to draw these diagrams from time to time. So let me redraw what's going on here so that you understand why I got to that conclusion. So you have this. Remember this assumes, you see this diagram on top, it assumes that there's at least two nodes. But then what if there's no node at all? Because we start empty, right? We start with nothing. So that's the diagram I'm trying to draw here at the bottom. So I'm gonna have this. So a white circle, remember white circle, we talked about that represents now. So I'm gonna scroll down here and then do this. So I have this over here, right? Copy, delete, and then here I have this. Oh, since it's null, since both of them are going to be sharing, we can just only use one null. So when we start, right, this will be the head, right? So this will be the head, and then this would be the tail, right? Head and tail, just like a coin flip, heads and tail. So there's the now. When you start, remember, like I said, head always, its previous always points to now because there's nothing behind it. And then, come on, and then its value also be null because it's not actually a node, right? It's not an entry into the list. It's not linked to the list. It just allows us to keep track of the first node. That's what the head is for. And then next, remember, you see, there's no in between node here. So it's going to point straight to what? The tail. Because there's no node in between. If you look at the diagram above, next pointed to the first node because there was a node. If there was nothing, it was just going to go straight to point to the tail because there's nothing, it's empty. But then previous, it points to now, right? Remember, tail, everything points to now. Everything points to now. The next, the value, everything points to now, right? So there's everything, right? They all point to now. When we insert something new, we change around the pointers. So that's why diagrams are very important. Even your lecturers are keep on advising you to do diagrams. So I can see that this means that this is next. Because obviously, if you look at my diagram, my next points to the tail. So I know for a fact the first parameter in this node constructor is a next, right? It's node type T next. That's how I knew I had to investigate, do a diagram. If I didn't have a diagram, it was going to be an issue. So let me just do this so that it's easy to read. And then now we are not sure what's the next parameter, right? The next two. How do we get to how do we conclude what are the next two parameters? Well, we need to scroll down and see if there's anywhere else where it was used, where they instantiated using the construct. If we see that there's nothing else, just look, scroll down, you see nothing, empty. There's nowhere else where it was used. So that means the other two parameters, that's up to you. I know it's a lot. They want you to get to that conclusion. Yeah, they don't call it a com sci degree for nothing. It's not an easy degree. So they want you to get to that conclusion by just inspecting, investigating the code. So that means I can put it in order. I can pass in previous first or the value first. That's up to you. since I've already passed a node, I'm gonna pass the next another node, then the last thing should just be a value. That's how I'm choosing to structure it. Remember, you can choose to structure it in whatever way you want to structure it. And then the last thing is the value. I'm I'm choosing to name them exactly the way I've named my instance variables on purpose, so that I force myself to use this keyword. Because remember, if you say, remember this, the constructor is its purpose is one is it has two purposes. Number one, to create the pod, to build the object, and to give the value the instance variable initial values. So now I need to give them initial values. So next is equals to next, and then previous is equals to previous, and then value is equals to value. But then you see that there's a warning, and I know the warning because the computer is not as in, okay, even you, if I ask you right now, which next is which, you wouldn't know. So the way it's gonna work is that Java is gonna think you're trying to do what we call self-assignment. So the way Java works, right, or any language, the way it works, it starts with the immediate, the one that's currently there within those curly braces. So that's it, Java, the way it's looking at, it's interpreting this code, it thinks you're trying to set this parameter next to itself. That's what it's doing right now because that's how programming works. It looks at the immediate, anything within these curly braces, it starts there, then it goes out. But then in this case, it won't even go out because it's like, oh, it's next, you're using next again. So it's gonna start next on the left hand side and look for it within these curly braces. You see this curly brace here, there, and then this, meaning within the construct. And it says, oh, you mean this parameter. And it goes to the right hand side. Next, it starts looking here. Or it says, oh, it's this. So you're trying to assign to yourself, which makes no sense. So Java is like, yeah, that makes no sense. So that's why you need to say this. I mean, the next that's outside of this constructor should be taking the value of the next that's within this constructor. So that's why I'm going to use this keyword. Then this keyword is used to reference the current instance of the class. And then I'm going to create Java doc. And then yeah, you don't have to write. I don't know why students they don't put Java doc. If you look at the marks in there, where is it? I saw it somewhere. You must provide appropriate Java doc for every function, class, and instance variable you complete. The Java documentation for your assignment should be generated and uploaded as a separate zip file. Or, yeah, my bad. I didn't know that part. I was hoping some students with this practical. Yeah, I didn't know about that, but I didn't read. Yeah. So that's it. That's important to read. So if you check here at the beginning, right, you must include your Java doc and yeah, yeah, this. So actually the the tutor is actually lenient because if you check here, it says you must include your Java doc and an executable Java file for each question in your submission. If you do not include, you get 0 for the entire question. So that's why I'm saying it's important to read the question. So yeah, so it's important to read the question. You guys must read the question. So I'm gonna scroll down. Yeah, okay, they didn't show marks, but then you see those instructions that you must so do the Java doc, blah blah blah. So make sure you do Java doc for every function, everything. Just they said everything basically. Everything that you write, you must do Java doc. So I'm just gonna say this is the next node. Next node what? Address or reference because this is Java. So next node reference, and then this is. Am I even recording? Okay, it's recording. I don't want to make that mistake that all this time it's not even recording. So this is the previous nodes reference, right? And then this is the value of the node being created. Remember this constructor, what we talked about, constructor builds or creates the object. So that value is the value of the current node that we're building. And then this just sets the previous, it sets the address of the next node and the previous node of the current node, the current one that we're creating, the new one. Because if you look at the diagram, let me go back to the diagram again. If I copy this and I paste it there and then I put it up, let's say I'm trying to insert this new node into this already existing linked list. What's going to happen is that I need to give it initial value of which this is going to be set via this constructor. I also need to update that new node's previous and its next. So that's what the constructor does. As you can see, there's the code here. I hope that's clear. So let's do the other basic stuff now. So all the other basic stuff is just accessors and mutators. If you check your P, what was it? What's that? Did I delete it? Hey, me and deleting things. I don't think I have it. But then if you check, there was what's that thing? PowerPoint presentation of what you're supposed to do in the practical. They did mention that you need to create accessor and mutator methods for this class. But then you can quickly pick up what's missing and how to name them. You see, another important thing, how to name those accessors and mutators. Let's start by the constructor. You see, it's showing me an error that it's such a thing or such a function or method is not defined. It's called set prev, meaning set previous. It just prev as an abbreviation. That's how you should name the function. You name it something else, this code will never compile. So that's why I'm going back and forth, delist and then go back to node. And you see all when you add things that are missing, the errors disappear. You see when I'm instantiating here, the errors now they're gone because there's a constructor that matches this constructor, which takes in three parameters. And then set prev. So we need to create that. So I need to, and if you check the practical, like I said, it says to create for both or the necessary, I think it phrased it as the necessary accessors and mutators, meaning I need to have one for this, both access and mutator, one for previous, both access and mutator, one for next, both access and mutator. So you need to do that. So let's do that. So I'm gonna say public void. Okay, let's start by the accessors, right? So it's gonna return a node. It's called get next, and then it returns next. Remember one thing about this keyword, right? You only use it if there's another name that's conflicting with the current name that you've used to name your instance variables. In this case, there's no other, within this curly braces of this function, right? There's no other variable named next. So I don't have to use this keyword. And then I'm going to create the other accessor. So get next, I'm assuming it's going to get prev. I'm assuming because this called the function to set called set prev. But then if they haven't used it, right? If they haven't used set prev, you see that's the thing about this question, right? You really need to understand what you're doing and know how to read and follow instructions. So if you look at get next, there's get next here. It's already used, right? But then I've already declared it, so the errors are gone. But then I don't see a set next or set prev or previous. So that means that's open-ended to me, right? I can name it in whatever way because it's not already incorporated in the code that was provided. So I'm gonna call mine get previous. I don't like to name things like get prev. Prev, what does prev mean? So I'm gonna just write it in full. Get previous. So return previous. Previous. And then public okay, public T value. No, get value like this practicals are not easy if you don't follow instructions. You see, for example, I call this get value, but then I really need to be sure that they named it that way. So, of which they didn't. So I'm gonna scroll down and I'm gonna show you get, yeah. So you see, there's the function here, get element. So I'm getting the next node, which is the first node, and then dot get its element. Another word for element is value. So that means this is actually supposed to be called get element. So you need to be very, very careful. Okay, I changed my mind. Let me call this just get prev. Just to be consistent. Why am I saying so? Because there's the mutator is called set prev. So get prev, set prev. It needs to be consistent. And then I'm gonna have public void my mutators, right? So void set, we're gonna start with previous set prev. Don't say previous because that's not how they expect you to name it. And then it needs to take in a node or an address or a reference that I'm going to update it to, right? So I'm gonna name this previous. So that I can just use this keyword. I like using things that I built into the language. Because my question is, if you don't use them, then what was the point to begin with? So they shouldn't even have implemented them. So that's why I use them. So public void set next. There's no set next function that has been called inside dlist. So you can call it whatever. You can call it set next node. That's up to you. But then I like to be consistent. So I'm gonna say set next. And if you remember how you name your accesses and mutators, you know that this is actually the correct way to name it. Okay, not entirely because this is actually called previous, not prev. So I should have actually called the set previous and it in this get previous. But then, like I said, the only reason I'm doing it this way because I looked at the code that I was provided, that it expects me to name it that way. Then I'm gonna update the next node. Then the last function is void set. We call it get element, so they expect to call it set element. You don't have to name it that way, but then like I'm just saying you need to be consistent because you can't write code and then your own code confuses you. You can't do that. So just be consistent so that you don't have to quickly go back and forth in your code and look and ask yourself, kind of what did I call that function? Oh no, it's not get prev, it's get previous. Oh no, it's not get prev, it's get previous node. So you see, you end up confusing yourself and you're the one who wrote the code. So try to be consistent. So it returns the next node's reference. Yeah, this Java doc is very important. If you look at the practical and the previous node's reference. The thing is the practicals are done in session, so you actually don't have the time to be doing the generating the Java doc and stuff. So I think that's why they're a bit lenient. So this returns the value of the current node. Because remember, these are instance methods, right? Meaning they can only be called when you create an instance of this class. And they're specific on that, they're based on that instance. So that's why I say current node, meaning that current instance that's using this function. So previous, this means the previous node's reference. And then next, this means the next node's reference. And then set element, this is just the value of the current node. And then done, it's not entirely done. I'll show you, I'll explain why. So let's go back to the dailies.java class. As you can see, this error is gone now. because I've created set prev and I've named it exactly the way they expect me to name it, set prev. Then I scroll down. If you scroll down to toString, right? Yeah, there's a toString. So you see that the header file, the header node, right? It calls the toString function. So that means your class, you expected the node class. Remember, header is an instance of node class. If I click here, it should show me about node of parameterized type T. So that means in my node class, I need a toString class, toString function. If you check your PDF or your practical, you see that this is the assume, right? This is assumption. On my assumption, I'm looking at this, I'm seeing, oh, if it's true, if it's like this, that means it's empty, right? And then it points to this and then points to that next. Oh, okay, I see. So this means that this actually represents the head. And if I go back, if I scroll that side, okay, what's going on here? I don't know what device doing that, my laptop. But then let's look at here. You see on both sides there's empty angle brackets, right? So that means that for my assumption, I'm gonna look at it as like, oh, this is the tail, this is the node. And if you look at our diagrams, both the tail and the node, their values are what? Null. Their values are what? Null. So that means when I have a null value, I should only display empty angle brackets. Otherwise, I display the angle brackets, and then within the angle brackets, I put in the value, as you can see, and followed by a space on both sides, the left hand side and the right hand side. So let's do that. Let's do the toString. So we need to override the toString. So to override the toString, we use what we call annotations. So you say at followed by the annotation. It's just for the developer, right, and the compiler for you to know. It's not basically I can put it in this way. Annotations is just for the aesthetics. It's not really mandatory. It's not like your code won't work if you don't put it. It will work. But then it's just there in Java to make it easy, the developers' lives easier. It's what we call it stores what we call metadata, which means data about data. So it's data about the data. So metadata. So that's basically what an annotation is. There's nothing much to it. So the function that I want to override is the toString function, which returns a string representation of my the string representation of the object, right, or this class. So there's many ways you can to when there's a lot. Do you know how many formulas I'm thinking right now? There's a lot of ways to solve this. Let's solve this using what we call a ternary operator. If you remember ternary operator, it's this operator with the question mark followed by the colon. So how does it work? So the question mark, it asks a question. For example, is it raining? Question mark. And then if it's true, it does something when it's true. If it's false, it does something when it's false. So is it raining? Get an umbrella. Something like that when it's true. If it's false, go for a jog or something. So that's basically how a ternary operator works. So you ask a question, and then based on that question, after the question mark, that's when you do something when it's true, when it's in the true state, when the question is actually true. And then after the colon, that's when you do something when it's actually false. And what happens is that this ternary operator, it returns whatever you said it must do when it's false or true. It returns it, so you can store it in a variable. So me, I actually want to return a string, so I'm actually gonna return a string. So I'm gonna return the ternary operator itself. So what question is the ternary operator asking? Remember, if you look at the diagram, the values for tail and head are null. So I need to check if value is null. So question, I'm just gonna put parentheses to make it easy to read, right? So check if it's equals to null, question mark, right? That's the question that I'm asking. If it is null, then what should happen? It should give you back a string. For both sides should give you back a string. Here it's gonna give you back a string, but an empty and a string with empty angle brackets. But then spaces on both left and the right hand side. So space on the left, then angle brackets, and then space on the right. And then there's this is what should output if the value is null. If you don't do this, right, do you know the problem of if you don't do this? If your value is null, the output is gonna be show like this. It's gonna have null in angle brackets, which means your output is incorrect. So that's why I'm doing this. And then if it's correct, right? If it's correct, then it should return angle brackets. Where is it? Angle brackets, right? And then within the angle brackets, there's the value. Like I said, there's many ways to solve this question, right? There is a lot. I'm not gonna lie to you, there's a lot, especially when it's false, right? Meaning that the value is not null, meaning value has something. So when the value has something, we can just output the value. There's many ways to do this, right? Let me show you two ways, right? You can go to the string class and call the format method, string.format, right? And then you pass in the format, right? In both ways, you use something called formatting, whereby when you use percentage %d, it means that it's an integer, whether that's a short or a byte or a long or an actual int. And then percentage %s just means it's a string. And then percentage %c just means it's a character. And then percent what f just means that it's a float or a double. And then if you want to show, so what happens is that in places of this combination of letters, it's going to replace it with actual value. That's what it means. So for example, if I say string dot format, let's say I want to output in XY coordinates, right? So I'm going to do this and say comma, and then semicolon. And then that string, I'm going to say comma. I pass in the values, right? It's a list of values, one or more, depending on how many sets of these things you have. So I'm gonna say, remember it's XY, so it's integers. So percent D, comma, percent D. And then the values will be X, comma, Y. Because I need to pass them as a list. So one by one, I need to say X, comma, Y, comma. If there's more than two, then I'll pass as many as I want. So if it was a XYZ plane, it would be X, Y, Z, and then this will be comma percent D because there's three of these percent D things. So what's going to happen is that it's going to take this value that you've passed in that same in the chronological order. It takes that first value, it replaces it with percentage D. So let me actually put values here so that you see. So let's say 13, 14. So what happens, what Java does, right? You say string.format, and this function returns the string. So you can store the string in a variable or write this whole thing within a system.out.println code. So like this. So this is the approach that I wouldn't advise you to use this one. You need to know your stuff. So like this, that's what I mean. Or you can just store it in a variable, then output the string. So the string.format returns the actual string, which is fine because we want to return a string. That's why I use string.format. And then what happens is that it's going to output those round brackets followed by the actual values. What's the first value? It's 12. It looks for the first percent D there it is. So it's going to say 12 here. followed by a comma, followed by another percentage D, which is another integer, 13, and then 14. So it's going to return this string. I should have put spaces there. So you can also put spaces that it also outputs including the spaces. So it's gonna return this. Then you store that in a variable, then you output it using the standard output stream, which is system.out.println. So yeah, this is what one of the approaches that you can use. So the way I want to do it is I want to have anchor brackets there, percent D, wait, percent D. Oh yeah, it's a problem. Yeah, I don't use this method. My mind totally forgot. Why we can use this method? Because of this T. So at least now you know in your next practical that you can use this function. But then that's not necessary in this scenario because it's just T. So if it's just T, right? Since you don't know if it's percent what it is, right? So you don't have to use this method. You can just use string concatenation. Remember, starting from left to right, anything that you concatenate to the string, it gets converted into a string before it gets combined with that string on the left-hand side. So even if it's an empty string, if I say empty string plus 2, this will give me, if I check the type of this will actually be a string of 2 like this. So as long as what's on the left-hand side is a string, or something that has two double quotes is basically a string, and you add whatever you're adding on the right hand side, it gets converted to a string and then it gets combined or concatenated. So what I want is that I want a space here, right? And then I want the less than sign. And I don't want a space after the less than sign. No. If you look at the practical, there's no spaces, right? If I zoom in, you see that there's no space here. There's literally no spaces in between. It's only spaces after and before the anchor brackets. And then I'm going to say plus. What's plus what? The actual value. And then plus the closing angle brackets. And then that space. And then done. So it can be a bit confusing if you don't know Java. So it's important to also from time to time revise Java. Remind yourself of the basic stuff. You see, this is basic. It's just ternary operator. If you don't want to do it this way, you'd have to use the what is an if statement. You'd have to say if value is equals to now, right? And then you return. But then you see how many lines? I'm already at 3 lines and I'm not even done. So that's why a ternary operator is very convenient. It's short, you see, sweet and short. There it is, done. And then I save my changes. You can always click there to save all, meaning save changes in every single file, every single .java file, save changes. So did that. So that's pretty much everything you need to implement. You needed to implement in the node class. And then always just before the class, you can put Java doc there and say at parem, and then you can just say this is the um generic type, right? And then you can also put like at author, meaning your name, right? So you can put your initials, something like that, and then surname, and then what is this? Student number. Because remember they said Java doc, so you get marks for that, I think. Yeah. But then they're a bit lenient because you guys are doing it in session. If it was a homework, sort of like the way they were doing it, sort of like a homework, you submit before 8 or before 9 Friday, every Friday or every Tuesday, then it will be a must for you to do Java doc. And then version, it just means what practical it is. For practical 3 assignment. And then you can just, if you for just extra information, put the year so that you remember. So that's pretty much how you can do it. Okay, no unders. Okay, it's whatever word they want, or whatever you want to do it. Put spaces or underscores, that's up to you. And then there we go. There's the full class. It is Java doc and everything is there. Let me see. Did I put Java doc for the toString? I didn't. But then I could just say it return, like what does it return? It return the string representation of the node class. You don't have to do that because I think it's because of the override. It assumes the Java doc is already there in the base class. Because remember, every single object inside Java, it extends the object class. You don't have to manually do it. It does it behind the scenes. So this object class, because why does it extend object? I mean, duh, everything in Java is an object. It's an object-oriented language, object-oriented programming language. That's Java. That means when the authors, when they're creating Java, they started from the ground up coding everything to work as an object. That's why even when you want to create a main function, you cannot create a main function in Java without creating it, putting it inside a class. So that's why everything in Java, because of that reason, they made every class by default inherit from the object class. So that object class already provides the Java doc, excuse me, they already provides the Java doc for every function that you override. So you don't have to actually put in that return. It's gonna put it for you. It's already there in the object class because this class automatically inherits from the object class. As long as it doesn't extend or inherit another class, therefore it doesn't directly inherit from object class. But in this one, it doesn't extend any class, so it directly inherits from object class. So far, do you guys have any questions? Yeah, there's quite a lot to cover. Eh? Do you guys have any questions?
Oh,
Okay. So I'm gonna assume since you guys have no question that you guys understood everything so far. As you can see, there's quite a lot to cover, to unpack. We haven't even touched the D-list class. So I think I should end it here. And then we're gonna continue tomorrow with the D-list class. Everything in the D-list class, it should be fairly straightforward, except this part over here. You see this quick sort? That's when you might have issues. Oh, that's where they expected you guys to have a bit of issues. But then we'll see the next lesson when we continue. We're probably gonna do, yeah. Um, so I need to save that diagram. I need to remember where I put that diagram so that I will just continue from here. I need to find that diagram. I think I know where it is, so I'm gonna look for it. Converting to an array, it's easy. That's not too bad. Converting converting to a list from an array, it's also not too bad. Like I said, if you find a way to like picture it and draw it and see how you can approach it, it shouldn't be that hard. So if you guys have no questions, I think that should be it for today. We'll continue tomorrow with the other functions.
Thank you.
All right. So let me stop recording. Yeah, I stopped recording now.